Okay, it's me, Gilbert, with HPDS. I think I'll go ahead and get started now. Today, I will be working with Algorand. So let's take a look at what is going on here. Make sure I'm all set up. Got this out of the way. Got this out of the way. Okay, great. So, build the future of Algorand. I'm gonna actually. Okay, it's me, Gilbert, with HPDS. I think I'll go ahead. Okay, still having some issues here. But okay. So build the future of Algorand if you see up there on your screen. So this is the developer portal for Algorand. And I'm gonna go to the docs, of course, just like any other project. And so if you come here, this is where you could get started in working with Algorand. You could obviously here's the get started, get details, run a node. So it is a cryptocurrency that works similar to say Bitcoin. And of course, if you know anything about Bitcoin miners, Bitcoin you run I think they call it maybe the ledger or something, but you host a ledger, which is the same as running a node. And when you run these nodes, you're keeping track. Your server is keeping track of the ledger. So all the transactions that are being created with the cryptocurrency. That is what it means to run a node. To get details, I'm assuming it seems like that's how you get details from accounts, from transactions and so forth. And getting started, this is it tells you some blockchain basics, for example. So if you don't know what a blockchain is, this is definitely where you want to get started with Algorand. And I myself, when I started working with this just about a month ago now, a little over a month ago maybe, I didn't know how a blockchain worked. I've heard of these cryptocurrencies such as Bitcoin and Ethereum and so forth. Of course, the Doge coin that is out there that's real uh, popular for some strange reason, but there are different cryptocurrencies and they run using these blockchains. So if you notice, I'm gonna go ahead and go over this just a little bit. So a blockchain is there's a blockchain ledger and then there's traditional ledgers. And here's what's interesting. You've got decentralized and you've got centralized. And I think that's what kind of this goes over. The old way, you see the traditional ledger, somebody came, made a transaction, and it went to a server, like a database. But now the new blockchain ledger, it's a blockchain, so it's decentralized. It would be kind of like the equivalent of seeing a database in multiple computers. Whereas currently the main system is most people make a transaction, that information goes to a database. That database could be owned by anyone, so any of whatever maybe online store that you're purchasing from, they would own their own database with their own on their own servers on their own hardware, and no one would have access to that data except for they themselves. So of course, if you think about a centralized platform like this, you can see that if you give your information to somebody who then stores that information on their database, they are the owners of that data and they are the owners of that database, and therefore they can actually manipulate all kinds of data. As a developer, I know for a fact that if you send me information on the internet, I could potentially store that information on a database that you would never know unless of course you went through my code on the server. And obviously that would be something that you may not know. For most websites you go to, you have no idea what information they are storing on their server. And for the most part, I guess you could say we have these notifications, these privacy settings, and that's why privacy was kind of a big issue so many years ago. And that's why you now come to websites that have all kinds of information about what kind of cookies they collect and so forth. They have a whole privacy policy on most web pages now. In fact, if I scroll down here, let's see if they have a privacy. Let's see their privacy policy right here. If you click on it, this website has a privacy policy. It's right here. It tells you where it's located. And if you go here, chances are it'll tell you what they, see they they got let's see, you'd have to read through all of this, but database requests. See, it tells you right there. We may need to check any personal data provided to you against publicly available databases. So they're telling you that they're using data. Here's processing data. They use Google Analytics. We reserve the right to monitor, check, and process your personal data if necessary to investigate or obtain evidence concerning any complaint, claim, or dispute. We also collect, process, use, and disclose personal data where required or permitted by law. So this is all just a fancy way of saying we have access to your data. You don't necessarily know what's on it. We will use it for whatever purposes we need, especially if it's going to protect us legally. And also right here, we also use and disclose personal data where required or permitted by law. Permitted by law means if there's not a law against it, it is permitted. So if they want to sell your information to China because it's not illegal, then sure, why not? And of course, that's just a over broad statement. I'm not trying to say anything bad about Algorand. I'm just saying in general, that is what it means. And that's why these platforms are kind of going decentralized, because that's a centralized ledger. So if there is a financial institution, which I'm sure there are many, and I'm not going to say anything about that, but there are financial institutions out there keeping track of your credit card transactions, and pretty much they're the only ones that have access to it. And though you may not know, like I said, as a developer, I know for a fact that they can then go into your data and they can manipulate it however they feel like is necessary. So if like one of these, crazy movies like I don't know, Eye in the Sky or whatever, one of those movies where the government is chasing after an individual and all kinds of crazy things go wrong, where they shut off their bank accounts and they do this or they do that and they're using every camera in town to locate, one of those kinds of movies. Um, those people in particular would be able to, for example, change your transactions. They can make it look like you've been making purchases that you haven't been making purchases of, or they could delete purchases so it's like you never bought something. They could just do that in their database because it's centralized. They're the only ones that have access to that data, and they can manipulate it, share it, change it, do whatever they feel like it, and there's nothing you can really do about it. Now, the opposite is these decentralized, and that's what the blockchain ledgers have kind of come out for. So now, instead of it being held on one database, these transactions are held in on public ledgers on these nodes. And these nodes, that's what they're called. They're distributed across multiple computers, which are nodes in a network. All of these nodes work together using the same set of software and rules to verify transactions to add to the finalized ledger. So you see now all of these computers, instead of just one server, one company, one owner of data, uh, then now a bunch of people own it, and they all make sure that it is the same. So when they check with each other, they say, "Hey, did this person make this transaction for this amount of money?" The other computers are saying, "Yeah, that's exactly what happened. We see that same transaction. That's exactly what we got recorded. It works all the same." Whereas, so, for example, say one of these computers on the blockchain decided, "Hey, I'm going to try to manipulate data, and I'm going to change this transaction that this person made over here to make it look like instead of paying, $10 that they paid, I don't know, $5 or whatever, then when they change it on their node and they change it throughout their blockchain, through their ledger, now suddenly when the other computers are checking it out, when these other nodes decide to say, hey, did this transaction occur for this amount of money? This computer right here, this node, uh, that has the false information might be the one asking, or might be trying to do something with that transaction, trying to put it in an app or something that shows somebody on somebody's phone or whatever that says, hey, you've got, $100 instead of $500 because we took out some money for whatever reason. These other computers can verify and say, hey, we never saw that transaction. Where did you lose $400 or how did you gain this much money, or we don't see any of these transactions that may have occurred that you have on your ledger. And so since none of us have these transactions, or these transactions don't match for whatever reason, then we're going to go ahead and deny this new transaction, or we're going to go ahead and realize that this is not a trusted source. This node is not to be trusted. And you know what? The rest of us are not going to even deal with that node because it keeps kicking out fake information or information that doesn't line up with the rest of us. So that's what it means to be like centralized versus decentralized. So now they're going decentralized, and this decentralized just really helps to keep track of just to keep really keeps track to make sure that uh unvalidated, like invalid changes were not made. Whereas in the traditional way, of course, you cannot necessarily trust it. You can only trust that server and that owner based off of how much you can trust the owner, the computer owner, and their team, their company, and so forth. And of course, if you look more, there's some more pictures, comic books talking about something like that line. You see where it goes, where here goes right here. I'd like to make a 10,000 bid on a house. And so, they're making the bid, and then your bid is confirmed. And that's the way it is with the ledger. There's multiple computers saying, I agree. This looks legit. I agree. Same. All these computers agree. Whereas right here, I think this is the traditional way. Here I brought $10,000, and I can't even read what they're saying. It's so small on my screen. Let's see, but was that 3 or 4 zeros? And they say that was 4. Here's your receipt. So you see right there, trust us. You paid us $10,000. And you just gotta trust it. That's it. Nobody else knows. Only that one person knows. That bank could suddenly delete that transaction and say, "Hey, you never paid us that $10,000." And that's what I was kind of hinting at earlier. So this person's already, they're already laughing. That's what they're saying. Only these people own that information, so you really have to trust them. Whereas on the blockchain, you've got multiple sources telling you if it's legit or not. And so then the block part, obviously you've got blocks. Every block is a let's see. The block part of a blockchain refers to a set of transactions that are proposed and verified by other nodes. So you kind of need to start knowing how this works so that you can start building transactions, because you need to know that when a transaction is created, it needs to be signed and it needs to be added to the blockchain, and then there's so forth like this. And because it works a certain way. So basically, if and it says right here, and then on top of that, what you have is, I think it doesn't say right here, it uses hashes. There goes hash block. So every block contains the hash from the previous block. And that's how you could tell, because you got the blockchain. Every block is a transaction. You notice right here, transactions data. Then you got block 2, transactions and data, and it's got the hash of block 1, where the block 1 actually has the hash of the genesis. And so there's a genesis block, which is basically the block that begins a brand new blockchain. And if you know anything about Bitcoin, this is kind of where you get the concept of Bitcoin mining. Ultimately, all around the world, there's computers making transactions, and when these transactions occur, they send the record to the entire network of Bitcoin miners. And ultimately the first computer on the network that actually hashes out the transaction and then sends back the transaction, that's the genesis. They got it's like a privilege to make this genesis block. Like, this genesis block is really important because it starts the blockchain, and then this blockchain goes for a certain while, and then you start another genesis on a new block. And so it's whenever the computer that's fastest to make the very first hash and then send it back, and everybody else the next so say you've got one transaction and you've got 3 computers, let's say, and the transaction goes to all 3 of them at the same time as best it can. Of course, and this changes in the world of computers based off of how close you are to the transaction, because how good your internet speed is. It also depends on how good your computer hardware is. And so the faster your computer can actually generate the hash and resend the information, receive hash, resend it, So it all depends on the speed of the computer, the speed of the internet, the proximity to the transaction, all kinds of methods. There's all kinds of variables. And that's why we have this issue where they're saying that it's unsustainable in Bitcoin, that it uses up too much energy because these computers are just running on full power as fast as they can, trying to be the first machine to create these Genesis block, because the first person to create this block in, say, like Bitcoin, they earn the little bit of Bitcoin that is mined. So all these other computers, they may be running at high speeds, but if they're not the ones creating this Genesis block, then they're basically just running on high speed for nothing. And that's what ends up happening, I'm sure, on many blocks, many setups out there. And so this is one thing that makes Algorand a lot better, because it doesn't have that race to the finish. It has a different means of consensus, and that's what they kind of mean by it. It doesn't leave as big a footprint because all the nodes, they're not out there racing each other, so you don't have to run them on full speed um, in order to try to earn a little bit of Bitcoin, a little bit of Algorand, for example. That's just not how it's working. It's got a different system where it's got two separate addresses, where you got the fee sync where all the transactions go to, and then it's got like a reward pool, and that's somewhere in here in this. I can't remember where it's at, but it's somewhere in here. So it's not quite the same, and therefore you don't have a race to the finish, which means you don't have a bunch of machines out there operating on full power, using up a whole lot of energy. And so, of course, and this keeps going on, and it also helps with that. That's how the hashes work. So that here's this guy right here. He's changing. He goes out there and says, "You didn't pay us $10,000. You paid us $10." That's what they were lying, right? That's what they were joking about or smiling about up here. And then of course she goes, "Hey, I paid $10,000. If this was the blockchain, she goes, "Hey, I paid $10,000, didn't I?" And these other people be looking, "Yeah, we saw that you paid $10,000." Whereas this guy says, "Well, you only paid $10, or you only have, see, you don't have that much money in here." And that's where, say for example, that is the bank, and the bank has tried to change information, and she goes to that bank and says, "Hey, I've got $10,000," and the bank is saying, "No, you only got $100." Well, the rest of the network would be, "No, no, we see 10,000. We saw that transaction," and so forth, etc. So when you first made the transaction, we clearly saw that it was for $10,000, not for $100. And that's what it's kind of saying right there. So that means everybody else is, "Hey, we're over, we see this right here." And so that's kind of what this is all about. And let's see what else. How will blockchain benefit from my application? Blockchain, as its core, is a technology that innovates on how we transfer value. So if your application exchanges value in some way, blockchain may be a candidate technology to bring your application to the next level. So what it's saying right there is saying blockchain is a technology that we use to transfer value, meaning to make transactions, like just like a dollar bill. It is a cryptocurrency. That's what the word currency. It's not a dollar currency or a paper currency or a metal currency like gold or silver or something, but it is a digital currency. And it's cryptographed because that's what the hashes are. The hash is a crypto signature type deal. And so basically a hash in the crypto part is that all the transaction data. So, like any kind of receipt, if you think about you going to the store and you receive a receipt, there's all kinds of text on that receipt. And that text might say like the date of the transaction, the time of the transaction, maybe the name of the cashier, maybe the obviously like the amount that was billed, the invoice amount. Then you also got the amount that was paid, and then maybe you got the refund or the cash back, or maybe talking about the Visa card or MasterCard, the credit card information. Maybe the store information, if it's like a chain restaurant or something, maybe it'll have an ID of the store. It has, basically what I'm saying is that every transaction has textual data, and that's what these blockchains, when the computer, with the overall program that is running, the Algorand program that they develop, it is getting this text data, and then it's turning it into a hash, which is a hash is, I think in this particular one it's 58 or is it 60 digits long? I think it might be the 60, but I also think I read it's only 58 digits long or 58 letters long, and it is a string of information. So it takes all of the data that's already in there, and what it does is it does it a cryptographic method and turns it into a hash, which is just a long string of indecipherable letters. It's just it's just a bunch of letters that don't mean anything to the normal person. But when the computer that hash is always the same when you run the program. You can't reverse the hash, meaning you can't turn the hash back into the text data that it once was, but you can always you can always change the text data back into the same hash as long as the text data is the same. So for example, say this was the exact same. We got block one, transactions, data. Everything's the same. Then your next one just says block two, transactions, data. If let's say everything is exactly the same except for this one says block one and this one says block two, so that one little number, that will change the entire hash. So when you come back later, when these other computers are, taking a look, it says this is the hash we have for this particular block because of, this is the information on it. And then you send it and this other computers look at it and it says, hey, this hash is not the same hash that everybody else has. Well, they don't necessarily know the data, but they do know that the hash doesn't match, meaning that at least one piece of information has changed. So even if it was just a, simple mistake or whatever, none of it, one letter off, everything changes. The entire hash changes, and that's how they're able to determine whether one hash matches the other or one block matches the other block. So that is kind of what is going on here. And so and you know what, I'm lost here. I was going off on here because I remember I was reading this each run nodes. So basically, but though, since that's how kind of I got into it, let me go back into this blockchain. So it transfers value, and so if your application exchanges value in some way, meaning you make transactions, you may be a candidate. Blockchain may be a candidate technology. So let's see how we innovates how we transfer value. So basically, if you make purchases or sales, you can use Algorand on your application, which is like on your website or on your mobile app or even in some sort of a video game, for example. Let's see. And we're going to go on. Let's see. These are some more just information about Algorand getting started. So I'm going to go ahead and I've gone over this quite a bit. I'm not going to go over the full page. I've already spent quite a bit of time doing it. And so now let's go in why Algorand. And I'm not going to go over this. This is just kind of what I was talking about. They don't have like the consensus protocol right here. It's that they sacrifice at least one of the security, scalability, decentralization, and so forth. So they're saying that Silvio, which is against the founder, that they came up with a new pure proof of stake consensus. So this is why, like I said, it's not, instead of creating a hash and being the first person racing to the hash, which causes a lot of sustainability problems, and they use the pure proof of stake, which means that they're doing some other means, and they have that's how they're doing their protocol, which means you have to go around and be set up to vote. So there's a different means. They're not racing. They're doing it based off of consensus, based off people that actually have Algorand in their accounts. And that's what it means to be the stake. You're holding stake. So the more assets you have, the more assets you've created, at least, you have to have a certain amount of algo in your account. And that's what they mean by the stake. So you need to have enough Algorand in your account to actually cover any transactions that you may potentially make. And so the more assets you have, meaning Algorand, the more Algorand you have, the more of a stake you have in the entire protocol. And that's why they use this consensus instead of racing. They do some sort of more democratic voting system, which allows everybody to not have to be racing to a finish. They can actually just earn more. And see here, right here, you got this right here. Come on over here, guys. no way, our money's worth nothing over there. You see, all this is kind of just how the Bitcoin is working. How these people are racing and they're just trying, and these guys are, saying something else or whatever. But anyway, so I'm not gonna go through this. I'll just kind of talking about that. This is just trying to convince you why you should use Algorand, and it's got a whole bunch of reasons why. And then we got, where do I start? And of course, this is where you want to get started if you need to make an app, or if you're gonna want to start creating an applications. I've already kind of gone over this. It really deserves a lot of attention. It does kind of talk about how you're going to integrate it and how you're going to do all this and that. But this is you really definitely want to get into. I think you go teach me how to build a D app, and you'll kind of see how there's different parts of a D app that they're talking about. And I guess they're trying to push Python maybe with the smart contracts. But when I get into smart contracts, I really plan on using Reach, I believe. Um, but it does have an SDK right here, and you can I use JavaScript. It's got Python, JavaScript, Go, and Java. And so each one of these on the left hand side, you see where JavaScript says your first transaction. And this is kind of what tells you how to build obviously your first one. It tells you you want to clone the sandbox, or if you want to make, this just makes up a sandbox for you. And you need Docker Compose, and you need Git. You don't really need to do that. I just did this version right here for JavaScript for runtime. So obviously if you've got Node, you do your npm init, you install Algo SDK, which is the Algorand SDK that you can find on npm, and then it also says that's the list version. So let's see. So that's kind of what you do just to install it. And when it does that, let me take a look. Let me push it back to my code over here. This was my code that I've already got going for this particular application. And I believe if you just go to the package.json, you'll see it right in here where you got your dependencies, your Algo SDK. And so Algo SDK, there it is right there. That's what happens when you do your npm init, or when you do your npm install. It'll write it there to your dependencies, as long as you do that correctly. Let me see, where else am I going with this before I start a new video? And so yeah, here we got this is how you install it, and then you've got your create an Algorand. And I haven't created an Algorand account yet, so I believe once I do the next video, I'll actually start making this. I didn't install it yet, or I'm not going to do a video about installing it, just because there's different means of installing it, and JavaScript is the one I'm working on. I'm not going to work with Go or Java, for example. So but what I will do is next video I make, I'll get into this creating an account, because the way I'm doing it, I'm not actually creating accounts. I'm actually let's see, when we go to my code, I'm going to be doing a standalone account. So let's take a look right here where we see, if we go to get details, I believe it's in the accounts, and then the creation methods, we'll see that there's 3 primary methods to create accounts on Algorand. So you got your wallet derived accounts using the KMD, and that's all part of the Algorand. I'm not going to really get into the KMD, because I believe that means that stands for key management daemon, I believe, as standalones or as multi-signature accounts. I'm going to be focusing on standalone accounts. And if you remember, let's go back to the app that I'm making. Here's, where I was working on it in some of my previous videos. So it doesn't look great because I was just talking about Tailwind. But if you go to dashboard, there's nothing here. So what's going to end up happening is I'm going to have a form here that will ask you to, import your wallet, in which you're going to give the wallet your address. And your address, if you could see, for example, is this long. This is what a hash looks like, for example. So this is just the test net. You can go ahead. This is all available for free out in the public, so I'm not too concerned about showing this. But here you'll see that this is a hash. That's my address. And so when you create an Algorand account, uh, the Algorand will actually create, here it is, a 25 word human readable mnemonic. So I'm going to go back to this page, the creation methods. Let's see. Right here. So you'll see right here when you're creating the account on Algorand, and this again is through the SDK or the documentation. It tells you if you know, and this is something that you need to know Node in order to do Node and JavaScript. You need to know how to require the Algo SDK. So you've installed it through Node, and here in a particular file, you're using that, you're importing it right here, and then you're going to create an account, which equals this function right here, where you try to do the Algo SD generate account. So Algo SDK comes with its own method called generate account, and you see right here they're saving my account in this generate account, from this generate account method, and then they're just console logging the address right here. That's the account address equals, or my account address, which is that. And then right here you got the let account mnemonic equal the, and so what you do is the Algo SD key has a function on it called secret key to mnemonic. So you get the my key, my account.sk, which I think stands for secret key, obviously. And then it tells you the account mnemonic 2 plus account mnemonic. So I'll kind of show this all. I think I will show this. I'll start doing this. I'll create an account and then I'll move into actually how to use standalone accounts. But I will go ahead and end this video here now. It's just a brief explanation on Algorand and how I'm gonna go ahead and incorporate it into this here app. And like I said, that's what I will do. I'll go ahead and get some. We'll mess around with Algorand accounts and creating them maybe, and then also generating them 25 keywords, and then also once we do get into standalone accounts, how we actually use an account that maybe you've created from already. You've created your account somewhere else. Maybe you've created it in the Algorand app, or you create. I could make it to where you create them here, but I don't think I'm going to start with that just yet because I don't want to keep track of that information. Or at least I'm not sure if I'm going to fit that into the way that this website works. But you will be able to put in your own account, and then you'll put in your 25 keywords, and then you will have access to your Algorand account from this application. And we will be using the SDK, and we will be using it ultimately. Past this is just a creation. Past this, we go to the SDKs, and or not the SDK, the REST APIs. So we're going to go to the REST APIs, and on the left-hand side, you can see how there's a few. You've got your Algo D, there's version 1 and version 2, and we'll be using this one as well as the indexer. The KMD, however, you'll notice this has, I won't actually be using the KMD. I'll be using, and that's because I will be using PureStake, which is the third-party Algorand API. And so this has access to the index and to the actual Algorand version 2, but it does not have access to the KMD. And that KMD, you actually, I believe you need to actually have your own node to have access to this KMD. So that's why I'll just be using the REST API, and we'll get it just from the indexer. You'll notice how you get different information. You get the health of an account. Here's the account itself. So you grab an account right here based off it's an account ID. And so obviously you just make calls to the API. You can include your account ID. And then also, I think when you sign off on transactions, that's when you need to have the, at a certain point, you need to figure out how to make the signature. So you see, at a certain point, you get your 25 words, you make a signature, and so forth. And I'll go over all of that eventually, but I am ending this video now. Keep that in mind, though. That's what I'll be working on, the SDK and standalone accounts using REST API. So thank you. Have a good one. And please like and subscribe, and I will speak more on the subject at a later time. Thank you.